Bismillahirrahmanirrahim. Hello everyone, this is another StaadPro tutorial. In this tutorial I'm going to show you how to use a physical modeler to model a complete structure and also apply loads, apply members, and finally design the structure. So this is a typical structure, 6 meters, HB is 6 meters in the x direction and 5 meters in the y direction, totally 2 and totally 3 in the y direction. So we have three kind of cross section. One is column, so we usually use 40 by 40 centimeters for the entire structure columns, and we use 30 by 50 40 by 50 beams in the primary beams, and we have one item beam or secondary beam here, and that is 30 by 30, and plate thickness is 50 centimeters. So totally three floor, and each floor has 3.2 meters height. We can call it multi-story RCC RC building. And here you can select physical model and create. So I use metric, you can use metric or another unit you want. And this is the 3D. You can first come here and which view you want to see. So this is 3D. Now we can go to grid, so you can create multiple grids and also multiple coordinate system. Especially this coordinate system need for special roofings or pitch, so that need to special angle, so you can draw it. But it's very simple, and just going to use this global coordinates, and also we want to create the this grid in the XY plane. So we have in the X2 totally H1 is 5 meters, in the Y we have 3 totally, in this is Y, which is the height of the structure, 3 stories, and each story is 3.2 meters. So we created one, and we can go to the one of the view, and here we can select member and select the member, and from one point to other point, and double click, you can turn off it, releases, and double click is okay, and again from here to here, and we finished one stories. So what's next? And now we can escape and we can go to 3D, and now I want to select this one and this entire elements. You can see the blue one means so it's selected, and we can go to the this command is called copy select elements or replicate. So this is a Z, so I'm gonna select Z along the Z. So the copy of number of copy is 3, and the spacing is 6 meters. So now I can go to preview. Before you can apply it, you can preview, see it's correct now. So 6 meters, okay. So now we've finished this one, and the second is we want to define the members. So you can select this point to this point, and the program automatically break from these two and show you there is analytical model. And now again from this point to this point, and this point to this point. So we created this beam. In case if you feel that is not okay, let's say I wanna replicate this one to here, but it's totally one. So let me select this is a complete. If I want to duplicate 3 meters here, but it's not, you can use this one, segment it, automatically break. So it will break automatically and make change to segments. So now I can select this one, and I can go to replicate to this one is by copy 1 along Z direction, and it's 3 meters. So I'm gonna go preview, and you can see here. So now we finished the entire beam columns, and now we want to create some surfaces. The first, let me create surface, and you can select surface and just go to select this entire, and you can see the entire surface is created. So the program will automatically will give you as a very nice mesh and connectivity in the analytical model. If I check call analytical model, it's called, you want to save it, and then you can, so it means member have no section, just they want to see the analytical model. So you can see the connectivity is completely okay, and we have a beam here, and everything is nice. So we can go back to the physical model, and now here I want to create one opening. So I can go to the you can select here a polygonal opening, and I'm going to select this node, and this node, and finally this node. So you can see we created our opening. Now next I can go to the member. I can go to one of the view, and let me define the column. So when you selected that column, you can go to member. So here is called section, but before section we can add materials is also okay, and so when you define the section, the material also automatically come to you, which is the default material. Now here in a catalog you should use prismatic, because we're using concrete and we want to define our and here is called rectangle. And now, so the first is the column is 40 by 40 by 40, 40 by 40, and I can calculate, and it will give me the properties of the column. So the material is here using concrete, and we go OK. So the concrete automatically is applied to these members. So the next is I can go to select the beams. So this was that beams, and if I go to one of the view and I select this one, and I can go to automatic to the member. So now again using prismatic rectangular, this is called section 2. We can give a name, it's called beam. So we can give a name, let's beam, or call primary beam, and I'm gonna go call primary beam. So the size is 0.5 the height and 30 in the width. So I can calculate, and it's the concrete, and I'm gonna call apply, and it's called yes. So here in its 3D we can go to the view and see the rendering, and you can see the beam column is added. So next I want to change this one and this column, so I can select it and go to member, and again using this again the same, and giving a name called the secondary beam, and the size is let's be 40 by 30, 40 by 30, and I'm going to calculate it like this. So I can call it, and you can see if I go back to the view rendering, and you can see this is a primary secondary beam. Now the next is we want to define the thickness for the slab. I can go to one of the view and select, and just go to the surface, and we can go to the first defined material, and the material is using standard here concrete. So it's already exists, and I'm gonna call thickness. So the thickness is Yeah, the previous one is called variable. In case if you have different techniques in a different direction, you can give variable. So I use constant, which is 0.15, and I'm gonna OK. Now you can see if I go to the rendering again, and you can see if I select the beam column, and you can see the thickness is obviously here, but this is the opening, and the opening is nothing. We finished the modeling first floor, and now what we're gonna do is I'm gonna go back to the modeling and select all, and I can call replicate, and this time along to y direction, and the copy is 2 more, and the height is 3.2 meters. Then I call preview, and you can see 2 other floor, and it's done. So the last thing is here, and this opening, and I delete this opening. So when I delete the opening, and you can see the entire floor is changed to the slab. Now if I go to the analytical model, and you can see, so there is no warning. The process was completed with warning. So here is the call surface that didn't have material. I wanna fix this. So now you can see if I go to here also in the rendering, and you can see the rendering is like this, and the meshing is quite nice, and the connectivity is fixed by the program. If I select, you can see if I select this member, and it's automatically divided with the it's just meshed with the plates, and now we can go back to the physical modeler, and in the physical modeler we want to go to select the entire models, and here, and the material. So the material is using concrete. So now the concrete is again defined to the members, everything. So now the error is finished. So next is the loading part, and also the before the loading we should create the boundary condition, and we can go to one of the view and select node. You come to the node, and here is called boundary condition or support. So I created fixed support, and you can see fixed support. And next we want to define the loading. We have two kind of loading, one is group load, one is load case. And so in case if you want to add some earthquake loads, you should create a reference load, and then create load cases. So we don't want to apply the earthquake load, so just we want to use this one. We want to add just gravity load, self load, and live load. So the first load case is dead load, and dead load. So I can say OK. The next is load 3 is going to be live load, and OK. So now we are done here, and next I'm going to select the surface, the entire structure. We'll go to surface, and I'm going to surface. Here is applying load, so I'm gonna add pressure as a load case 3. Load case 1 is self load, and the load case 2 is, if I go to the sheet here, and it's going to be load cases, and you can see what we have. So here in the category, I can select this, I can delete this, so don't need this for me. Delete selected load case, and I can, in the load case 2 is date load. I wanna apply the self load. If I go to select this one here, and you can select self load is -1, and we already selected the surface, and I'm going to assign pressure which is equal to the gravity load. So that's -1 kilonewtons in the y direction, in the load case 2, and you can see the load is applied to the entire surface. So next I can go back to the here uniform, and this time I'm going to load case 3, which is the live load, and this is 2.5 kilonewtons per square meters. So now we finished the loading. Also we can create some combination here in load combination. You can use the type of load combination. I use linear, you can use SRS or absolute, ABS or another things. So now we can select these two load case, and okay, and we can come to the automatic load combination. So we created one actually, so it's better to using automatic, and we can use which code you want. So I won't use AC17, and you also change some rule in case if you want. And so this is the rule. You can change it, but it's automatically using that ACI 17, and allowable stress, and also stress design. So when I accept it as it is, and now we select all, so we call create. So the load is created, the self load. So we finished the modeling and loading everything, and we can go to the analytical model again. So I'm going to go analytical model. It's called the model has been saved. So there is one error, which means some combination like snow load we didn't have, earthquake load, so we don't have. So we can go to the loading, and you can see we created two load case. So the self load, and is the another gravity load, and the second is this load. And this is the combination, and you can see this combination. So we are done here. We can go to the analysis tool, and we can call sorry, yes, I should define. So it means no, stop. I have to define the command of analysis. I can use all, or just no print. Loading, you can go to analysis tab and command no print, perform analysis. So there is one error which cause perform analysis is okay. Now we can go to run the analysis. So there is no error, no warning, just no. We can go to the post processing and okay, and I can go to here, enable this. This is also apply, and we can see the result. Let me the displacement, and you can see the gravity displacement is giving. And if I go to use beam result, and you can check the moment, forces, and also I can go to the plate result, and let me use 1 mesh stress and apply absolute value. So this is the result, and you can see here this is the plate stress strain. So we finished here. So the design of the concrete is depend to the advanced concrete design. I can design in the advanced design or RCDC. So here is the my RCDC, and I can use ACI code, and I select matrix, and I can call it first column design, and client is done, and yes, and I can select here from here, just column, and create project. So we select the entire columns, and we can the data is imported to the RCDC design. So now we have this column. You can see the size and the column, and now here we can change the materials. So that C25 is okay because it's a just a 3-story structure, and I want to use 30 millimeters. So we couldn't. So we can go to the design setting in case we can change the. In previous tutorial I have discussed about this. You can consider, and but here I'm gonna just go to auto design, and here this is called load case date load, and this is live load, and I can go to add. So now we added the load, and here is called the combination. I want to add from the analysis, and we have these two combination 1.2 1.6 1.2 0.5. So we're gonna call OK. We added a combination, and the program start designing based on this giving load. Now this is the design is finished, and there is green. All the loading is passed, all the column is passed. If I go to here, let's go to call interaction surface, and you can see this is the curve which is created. So this is the maximum moments in the XY direction in axial force, and also other parameters, and then finally ratio. So this ratio is 0.2, which is acceptable. And now it's called no ductile because it's just gravity design. We didn't considering earthquake design, so it's like this. Only generate BBS, and we can go to all column or just one column. For just C1 is okay, and I'm gonna you can use the rebar length because when you practically create the rebar configuration, so then you have to 12. So we have 1175, almost 12. So then the program will automatically give you the overlaps on everything. So then we generate, and it's generating BBS. BBS column is one column, so C1 was this through story, and you can see here here is the overlap in the middle of here, and you can see this is the cross section. We use ties and also straps, and for number of 19 and for number of 16. So this is 19 and this is 16, and this is the size of the straps and tie. And other section, this is section 2 in this area, and this is section 1, and this section 3. So you can see this is section, and you can see each area has totally same, which is uniform from bottom to top. And here is the table rebar shape, and also this is the total amounts of the rebar used in this column. So you can see the weight is kilograms. We need 10. From the 10 is 63 kilograms, and 69 and 100, and totally this one and totally this one. So this is the length and meter, and this is the weight. So the column is finished. We can save it. This is called save column. And next we're gonna go to new again, and this time we want to design beam. So beam is same with column. I'm going to use slab design, and called using 19, and I'm going to use slab. We can select one floor, or the entire floor as well. So let me the first floor. So this is the slab, and you can see. So we do not design this one because it is not. This is just opening. So we can select that one. This is S5, and we're not going to design that one. Even we can called, it's called 1/8 dimension, and this is 2. So now we can give the imposed dead loads. So this is the imposed dead load is 1 kilogram, and copy, and we're gonna call paste, and this is 2.5 kilogram. Copy, and we're gonna paste. And this is the thickness. We want to use 150 millimeters, and I can copy and paste. So this one is here, and we're gonna call it 0. So 0, 0, and 0. So now we applied the load, and we can go to design it. And here I want to select it. Here is called so I can use the same 2.5 and 150, Now I'm gonna run it. So it's start to design the entire slabs. Now the slab is completed, the design is completed, so there is no problem. We can quickly create a list using this automatic setting, and we create the BBS. So here the BBS is created. So one thing that the opening is added here. We didn't define actually opening, so we can remove that one from the design. We considering there is no rebar on that side. So this is the rebar. You can see the longitudinal rebar, horizontal rebar, and so like this. This is the total bill of quantities. We want to create some we can call some want to create some actually section. I'm going to call it slab section, and you can give the number of slab you want. So I'm going to give this slab number of slab. Let me give number of slab. You can select it, which is S, and this is S. Let me go to S1, this one, and automatically is taking the size, and I'm gonna call draw. So it's called left mark, and you can section mark. It's called let's go to be A, and this should be the technique, the left side, the length, left support, and the left support is 400, and 50, which is the top, and we can give mark 1 again. The right support 400 and 500. So I call draw, and you can see like this. So this is the section slab 1. So we also can create the stairs, and we can go to report and call the stairs section, and we can give actually list the span is 5 meters, so the height is 3 meters, and I'm gonna call it draw the stairs, and you can create the stairs. So this is the stair rebar. So like this. So now you can save it. Please save the project here. This is save it in the RCDC file. So now when you go to save, and it will create AutoCAD file, so DXF file. You can create DXF file. So we finished, and the last one is the beam. We go back to here, and this time called beam design. Beam design, and again giving gas and using the same ACI code 19, and this time called beam. So we can select the entire beam or just going to first floor. So we can select all, and it will import the program. So here is the entire beams, and you can select each beam. Here you can see the properties. So this is the beam, because the beam is divided in the meshes. So here is, you can see, but the total length is giving 6.4 meters, 9.4 meters from here to here. So what we're gonna do is we want to we can give the deflection. You want how much deflection should be, or allowable deflection, and everything. So we don't need to this one. I'm gonna automatic design, and again going to changing the dead load, and this is the live load, and I'm okay, and adding from analysis, and I'm okay. So we started designing. So the program will give us the maximum consider the deflection. So the design is completed, and you can see here all beam column is passed. If I go to see quick detail, and here you can see the detailing, and here is the moment and shear force, everything, and the number of rebars. So we can go to so let me close this one and go to again create BBS. So I can select the entire beam using the same default parameters. So it's generating yeah, here is the generated beams, and you can see we have this beam. So this is the beam, this is a rebar and number of rebars. We also can see some section. We can create some section manually. This is actually a section. We can go to report, and it's called design summary, and beam size change if you want something. Design summary. So you can see H beam is giving here, and the total shear force, torsion, everything, and finally it giving the design, shear design, and flexural design, and everything is giving here properly. You can save this, and later you can create it. So we finished here the beam, columns, everything. So now this is the end of the tutorial. If you have any question, please post in the comment, and I will find time to answer you. See you next time.